All right, we're going to go ahead and look at the Leslie matrix and how it's used in order to show the population growth within intervals of time over a lifespan. And so what you're going to notice is a table that's got age, and those are all broken into equal intervals of 3 months. We're going to show the birth rate of each one of those intervals and the survival rate of each one of those intervals. Now, in this problem, we are going to be particularly talking about the female rat population. Okay, and what we're going to do is we're going to start with a total of 42 animals. Now, I'm going to start with a table so we can show how this population is going to grow and how to make sense of building a matrix statement. So let's go ahead and start here. Right now, we have the population of each female rat within each of the intervals of time. So there's 15 that are 0 to 3, 9 that are 3 to 6 months, 13 that are 6 to 9 months, and 5 that are 9 to 12 months. And you can see that all listed right here. Now what we're going to do is we're going to calculate after one cycle, and one cycle is going to be 3 months. So as we calculate after one cycle, the first thing we really want to pay attention to is that we are going to have a new amount of babies because there is going to be a birth rate associated with each one of our intervals of time. So the first thing I do is I go ahead and say, well, let's go ahead and find the birth rate and let's write those down. So I know that there is a 0 birth rate, a 0.3 birth rate, a 0.8 birth rate, 0.7 or 70%, a 0.4, and a 0 birth rate. Now those birth rates all correspond with how old the animal is, or the rat is in this case. Okay, and so what we're going to do is we're going to go back to what we have originally, and we're just going to multiply it by how many there are. So there, the birth rate is 0 times 15 for the babies. Or 0.3 times 9 for the 3 to 6 months, and 0.8 times 13, and 0.7 times 5. And I'm getting these right off here, 9 to 12 months, 9 to 12 months, 0.4 right here times 12 to 15, which is 0, and a birth rate of 0 for the older rats. And that's probably because they're just too old to give birth. Now, in order to find out how many babies there are, each one of these categories have given birth, okay? And so I want to find out the total number of babies. What I'm going to do is I'm going to go through here and I'm going to add all of that up, okay? Now, I can go ahead and type it into Desmos, and you'll notice that's what this first statement is right here. 15 times 0, 9 times 0.3, 13.8. I just typed it in, and that gives us 16.6. So at this point, there are going to be 16.6 babies that are born for the next cycle. So after that cycle. Now what we're going to do is we're going to take it and we're going to find how many rats there are going to be that have transitioned. That's the really important part, that have transitioned to their next category. And that has to do with their survival rate. So we're going to go to their survival rates. And we're going to look at the transition. Well, what we know is there are 15 original babies, and out of those 15, some of them are going to become to 3 to 6 months old. Well, in this case, 0.6 of them will. So there's a 0.6 survival rate times those 15. Then what we're going to do is we're going to do the exact same thing. We're going to keep working it down. We're going to say, okay, well, we know that we have 3 to 6 months that are going to transition. Their survival rate is 0.9. So they're going to, those 3 to 6 months are going to become 6 to 9 months. And I'm going to say, okay, well, their survival rate is 0.9, and there were 9 of them. Then I'm going to say, okay, well, their 6 to 9 months are going to transition to 9 to 12 months. But out of those 13, 0.9 or 90% of them will transition. Not all of them. Some are going to die. They're going to get eaten by something. Okay, and then the 9 to 12 months are going to transition to 12 to 15 months. So I'm going to say, well, 9 to 12, they've got an 80% survival rate. So I'm going to say, okay, well, there's 5 of them. Let's multiply it by 0.8. Okay, and then out of those, the 12 to 15 months have a survival rate too. They've got a survival rate that's going to get them to 15 to 18 months. So I'm going to say, okay, well, there's 0 of them, which is 0.6. Okay, and then of course, check out what happens in the end. Rats don't live longer than 18 months. They usually die off in this study. Okay, so we're not going to even have to worry about that. Now, once we get here, we are simply just going to go in and we're going to multiply all the pieces. So 15 times 0.6 is 9. 9 times 0.9 is 8.1. And then 13 times 0.9 is 11.7. And 5.8 is 5 times 0.8 is 4. And then we go ahead and what we're going to do is we're going to look there. 0 times 0.6 is just 0. And then what we're going to do is I want to find the total. I want to find out how many animals are now in the study. And that just means we're going to add all these little pieces up. Okay. And if we go back to Desmos, we can just type in 49.4. That's that piece right there where I've just added them all up, 49.4. Okay. Now, what about cycle 2? A lot of people are going to go, well, what do we do with cycle 2? We do the exact same thing again. Okay, so if I want to go to cycle number 2, I'm going to go through the exact same piece. I'm going to say, okay, well, there's 16.6 babies, and I'm going to write down their birth rates again. So I'm going to start over with their birth rate, 0, 0.3, 0.8, 0.7, 0.40. So I'm going to write them all down again, 0, 0.3, 0.8, 0.7, 0.4, and 0. And I'm going to go back through and I'm going to start labeling how many there are in each one. Well, check it out. There are 16. So I'm going to write 16.6 here. So 0 times 16.6. The birth rate for a 3 to 6 month is 0.3. So I'm going to go 9 times 0.3, and I'm going to follow out the pattern, 8.1 times that. I'm going to then do 11.7 times 0.7. I'm going to say 4 times 0.4 and 0. Remember, I'm just following these patterns, ticking them off. Once I have that, I'm going to go through the whole process of adding them up one more time, and that will give me, after 2 cycles, which is a total of 6 months. At this point, I go back to the same problem. I say, okay, every one of these are now transitioning. They are now transitioning into their next group. Okay, so I'm going to say, okay, well, what was their survival rate? And we have them already written down. So the survival rates are going to be written here. So I don't even need to go back and search it out again. I'm just going to say, well, 16.6 times 0.6. And say 9, those 9 are going to survive at a 90% rate. I'm going to say those 8.1 are going to survive at a 0.9 rate. Okay, I'm going to say these 11.7 are going to survive at an 80% rate. And I'm going to say that these 4 are going to survive at a now 0.6 rate. And what's going to end up happening is we're going to add them all up again, and we're going to end up with a total. Now, how does this relate to a matrix statement? Well, the nice thing is we're given a matrix automatically, the nice, easy matrix to work with. We're given a matrix that has the number of rats in each one of those categories, or the population of rats in each one of those intervals. So I'm going to write those down, 15, 9, 13, 5. So 15, 9, then I'm going to come up here, 13, 5, 0, 0, 13, 5, 0, 0. Okay, and I'm going to take that matrix, and this is the population in each category. Now what we have to do is we just have to figure out, well, what is happening? What is making sense with this? Well, the first thing we do is we actually go ahead and we multiply to find the first spot. We multiply by all of the birth rates, and then we add. That is classic matrix multiplication. So I take the birth rate 0.3, 0.3, and then 8.8, 0.7, 0.4, 0.8, 0.7, 0.4 and 0. And then what I do is I go ahead and multiply them. And then I add them together. I take those answers and I add them together. Well, that's classic matrix multiplication, because all I have to do is take those birth rates and just put them into the matrix. And when I do that and I multiply, they're going to lay right over the top, multiply. Then we're going to add each one of those spots. That is matrix multiplication. Now you're wondering, okay, well, how in the world do we get the rest of this matrix to show up so we get the rest of the table? Okay, so let's look at that piece. I'm going to look at that piece one by one by one by one so it makes sense. Okay, the next thing that we want to show up is that we want simply to show up the number of babies that are in the 3 to 6 category, which is right here. And they are giving a survival rate of 0.6. Well, the only thing I multiply that by is 15, which is the number of babies. So all we do is we say, okay, well, I will multiply that 0.6 times 15. And that was in that first spot. And I didn't want to add it to anything else. So I'm going to multiply by 0 for the rest of the matrix. Okay, so I multiply by 0. Well, what does that look like when I put it right back into the matrix? Well, this becomes 0.6, this becomes a 0, a 0, a 0, a 0, and a 0. Okay, hopefully that makes sense. Now I just keep working it, and I want to go ahead and come back and I say, okay, well, now what I wanted to do is I wanted to find the next category, which was 6 to 9 months old. So I'm going to find the next category, which is 6 to 9 months old. How did I do that? I take 0.9 and I multiplied it by the 3 to 6 of the 9. So I took 0.9 and I multiplied it by this. I didn't want anything else to show up or add to it. I just wanted that one piece. So what I'm going to do is I'm going to put a bunch of zeros in here so it cancels everything out. I'm going to write 0, 0.9, 0, 0, 0, 0. Because remember, once we do this, matrix multiplication says we're going to multiply these pieces, and then we're going to add all those pieces up. And I don't need anything else to add to it. And that's why I'm canceling out with zeros. Now, you may begin to see a pattern with this. Okay, and what we're going to do is I'm going to keep following it through. I'm going to say, okay, well, I've done this piece. Now what I'm going to do is I am simply going to find the next piece, which is, guess what? 6 to 9 months old, and I'm going to say 13 times 0.9. So let's come back down here. I'm going to say, well, I needed 13 to be multiplied by 0.9, and that is the only thing I needed to show up. So I'm going to put zeros here. Well, check out what's happening again. 0, 0, 0.9, 0, 0, 0. Okay. Uh-oh. Maybe you're seeing a pattern in what's happening with those zeros. And hopefully you are, because now I'm going to find out, well, how many 12 to 15 months are there? Okay, let's see what it is. Let's go here. What did I do? I took 0.8 and I multiplied it by 5. So 0.8 times 5, 0.8 times 5, that's that. And that's the only piece I wanted. That's it. I didn't want anything else to add to it. So I put 0, 0, 0, 0, and 0. So 0, 0, 0, 0.8, 0, and 0. Okay, now check it out. One more time, I go to this one. I have that 0.6. Okay, so I'm going to go to 0.6. Let me get a different color there. Let's go with brown. I get 0.6 and I wanted to multiply it by that 0. Well, where is that? That is right here. Okay, you can start seeing this show up. Okay, and so now what am I doing? I'm going to fill everything in with zeros on the other side. So you could see that pattern. So I'm going to write 0, 0, 0, 0, 0.6, and 0. Now you will see this. Now this is the tricky part. Guess what? The last one, there is no survival rate. It is just simply 0. And notice that there is no more calculations that are going to be done. So what I'm going to do is I'm going to close out this matrix completely. okay? Now, that explains how the Leslie matrix is set up. So we start very simple. We write our population matrix out. In order to make our calculations, we're going to start with our population per category or age group or interval, however you want to think of it. Okay, we're simply going to write our birth rates in the first slot. And then at a diagonal, we are going to end up writing our survival rates. Now, if I want to know how many are in the second, this is the great part. I can make my calculations with matrix. If I want to go to the second life cycle, I just put a 2 up there. I just put an exponent. Okay, and that exponents will make all of our calculations. If I wanted to go to the third life cycle, I would say 3. This is our third life cycle. And I would continue to do an exponent off of the Leslie matrix that is there. So hopefully that helps you understand why the Leslie matrix is set up the way it is and how we make calculations with the Leslie matrix as well.